Okay, this final video to the spreadsheet series is going to focus on solutions to parts E and F. So what if the problem was manipulated so that there weren't four sides? Let's just think that perhaps one of the sides is the back of the garage or the house, or it's just a side that doesn't require any enclosure. Okay, so three sides. Just going to go and clean the spreadsheet up a little bit. I'm going to take these cells out because these are specific to four sides. So three sides. Let's go over here and clear out some of this information. But let's be very specific in what we choose to clear out, because some of the spreadsheet could still be useful. Okay, what won't be right now is the perimeter column, because remember, the formula we used there was specific to having four sides. The length isn't going to change because the length is based on the area divided by the width. Okay, so whether we have three or four sides, the area is not going to change. Okay, the area is not dependent on the number of sides you have. It's only dependent on each of the length and the width. Okay, perimeter is dependent on how many sides you have. So let's recalculate the perimeter. Okay, so we're going to use two widths. So I'm going to take 2 times the width value in cell A4, and to that I'm going to add the length value in cell B4. Okay, and there's our perimeter. So what I'll do is I'll copy and fill down through our table, and then we'll look for the minimum perimeter. So it looks as though dimensions of 3 and 8 and then 4 and 6 are giving me 14 as the minimum perimeter. Which I guess begs the question, could there be a width value that's intermediate to these that is going to produce a perimeter that's smaller, that falls in between those two 14s? That could be the case. So let's enter in a row, and in between 3.0 and 4.0, why don't we try 3.5? Let's copy and fill down and see what happens. And it does happen to be true. We can see it here, 13.9 is a smaller perimeter. And notice the relationship between the width and the length. The length is nearly 7 meters, which actually is double the width. And that's something that we discovered earlier on, was that for a three-sided rectangular enclosure, the perimeter is minimized. That is when the area is fixed, when the length is twice the width. Okay? Just add a few decimal places to that, as well as this one. Okay, let's just test this theory a little bit more. What if we tried a value such as 3.45? What would happen there? Let's test this out and see. It rounds it up to 3.5. Let's add a decimal place to it. And here we're going to copy and fill down. Okay. So 3.45 with a length value of 6.957 produces a perimeter of 13.857. Let's add a decimal place to that as well as this one. We'll compare, and by comparison you can see that this value is smaller. That is at 3.45 for the width. And note, by doubling that, we do get 6.9. And we could add one more row just to be more specific as to what the width and what the length will be. But suffice to say that these dimensions here, that is a minimum perimeter of 13.85, is being produced by these dimensions here. Okay, so we have come up with a spreadsheet answer to part E. Okay, but not to F. So that's where we move into another challenge. So at this point in time, take a moment to pause and reflect on what has happened in the video, and then move on and challenge yourself to come up with solutions to E and F. And once you've given it a try, play the video back and see if your thinking is consistent with what's being shown in the video. Okay, looking above you can see the table that was generated and the dimensions that produced a minimum perimeter. And in terms of predicting this, it was alluded to in the video that with 3 sides, the length is twice the width. Okay, and using that fact is going to lead us into this particular style of solution. Okay, so if the length is twice the width and the area is length times width, then have a look at what we can do. Okay, notice what's been highlighted here. We see the length here. We also see it here. So with this statement being true, that is conditionally, we could take this value and substitute it here for L. Okay. What that does is it produces this relationship. Okay. So you can see how the 2W was substituted for L, and you can see that occupying this position of our formula. Performing the multiplication, 2W by W gives you 2W squared. Okay? Now remember, we used the spreadsheet to determine the minimum perimeter, and that is we needed to figure out one of the dimensions. So the way we did that was by substituting the area and solving for W. Okay, remember how we divided the area by one of the dimensions to get the other one? So in goes the area. Then we'll begin solving. So we'll divide both sides by 2, and that'll give us 12 equals W squared. Well, W squared, to undo that operation would be to use its inverse, which is square rooting, and the square root of 12 is approximately 3.46. If we go back to our table, you can see how that value does approximate what is here for the width. Finally, with that dimension being known, we can finish the calculations because we know that the length is double the width. So doubling 3.46, we have 6.92. So the dimensions that produce the minimum perimeter, given a fixed area of 24 square meters, are 3.46 meters by 6.92 meters. Okay? So in conclusion, as these videos are posted, view them as many times as you need in order to feel comfortable with the material. Do take note that towards the end of the unit, or perhaps partway through, you might be presented with a performance task, which will be an assessment of your learning, which would be incorporated into your summative mark for this course. So be prepared for that. A good resource or a good tool would be to use the electronic textbook that we have subscribed to at McGraw-Hill Ryerson. This is Foundations for College Mathematics 12, okay, authored by Erdmann and others with a copyright year of 2010. So this is page 44, and have a look at this question here. Problems 7 through 10 are all based on the information in this question here. So either in class today or on your own time, it would be very wise or to your advantage to begin planning a solution to this problem.